So in this chapter, we're going to be learning a lot about different ways of writing what we call Lewis structures. The first types of Lewis structures that we're going to learn to draw are what are often referred to as Lewis dot structures of atoms, and it's a pretty simple process. So we're just going to review what we mean by a valence electron. So for a representative element or a noble gas, a valence electron is simply one of your electrons that is in its outermost shell. And for those elements that are in an A group, the so-called main group elements or representative elements, these electrons will always be in an S or P subshell. Now, an American chemist by the name of Gilbert N. Lewis, he developed a system to illustrate the number of valence electrons that an atom has pictorially. And it's really simple. We're just going to illustrate valence electrons as dots. So an atom can have up to 8 valence electrons, and we can put 8 dots around an atom illustrating the number of electrons that it has. So this atom has 1 valence electron. What we do though is we keep adding dots singly at each of the 4 compass points, and then we begin to double up. So this atom has 4 valence electrons. Now if I want to go beyond 4, I'm going to start doubling up. So this guy has 6 valence electrons. But what you'll see is I never put more than 2 electrons or 2 dots at any one of the 4 compass points. Now it doesn't matter whether you start at the top or the bottom, the left or the right, as long as you don't ever have more than 2 dots in any one of the 4 compass points, and you never put a second dot down until you've put 1 dot at each of the 4 points singly occupied. Kind of similar to Hund's rule. Okay, so here it all is for the entire periodic table. I guess the only kind of exception to our rule here is that these guys have illustrated helium with 2 dots, whereas according to my rules we would have put them as 2 individual dots. There's a good reason for them doing that. So what you see is everything in group 1A has 1 dot because those guys have 1 valence electron. Everything in 2A has 2 dots because those guys, you guessed it, have 2 valence electrons. Everything in 3A, 3 dots, etc. 4A, 4 dots. 5A, we see we're doubling up for the first time. 3 single dots and 2 double dots. 6A, they've all got 6 dots around them. 7A, 7 dots. And then 8A, they've all got 8 dots except for helium with its 2. So that's pretty simple, right? And for a representative element, an A group element, sometimes also called a main group element, the number of valence electrons is simply equal to the group number. So that's real simple to figure out. So what's interesting about this is that the number of unpaired dots that a nonmetal has, and nonmetals in this case are indicated in yellow, that indicates the number of what we call octet vacancies, which is the number of bonds that that atom tends to make. So these guys in group 8A have no unpaired dots, so they don't tend to make bonds. The elements that are in group 7A all have 1 unpaired dot, and they all tend to make 1 bond. The elements in group 6A all have 2 unpaired dots, and they all tend to make 2 bonds. 5A, 1, 2, 3, 1, 2, 3, they all like to make 3 bonds. Now you will see exceptions to these rules, but most of the time the number of octet vacancies equals the number of bonds that that atom will make when it forms a molecule. So the questions for this section are pretty easy. So this question is asking, draw the Lewis dot diagram for a neutral atom of bromine. So what's important about it being a neutral atom is it hasn't lost or gained any electrons. So bromine is in group 7A, so that means that it's going to have 7 dots around it. So bromine, you can go 1, 2, 3, 4, 5, 6, 7. It's got one octet vacancy. It likes to make one bond. This is a pretty easy topic in Alex. You just got to have the required information to hand. Okay, so that concludes section 11.2 on the Lewis structures of atoms. I think it's really straightforward. If you just remember, your number of dots is just equal to the group number. Okay, hope the video was helpful.